Today we are going to begin with our new chapter, that is electric current, that is current electricity, and it's very important chapter. Most of the questions are asked from this chapter also, and it is similar to capacitor. The circuit which we are using in capacitor, similar type of circuit you will see here also. So without any delay, let's start the topic. Now let us define what is electric current. It is said that suppose we are having one charge Q and it is flowing in a wire like this. If suppose at some cross section area, let us define one cross section area as A. If we define this cross section area as A and take unit per unit through this area, if we are considering one time, unit time, it may be 1 second, usually 1 second. In 1 second time, how much charge is flowing through this area which we have fixed here? This in unit time, the amount of charge flowing from this end, that is left end, to this right end, the amount of charge is called as current. The amount of charge flowing from one end to other end through a given area in unit time is called as electric current. That I have written here definition. You can see. Okay. Basic definition of current. Usually what happens? In a conductor like this, if suppose we are having one charge Q is flowing here. Okay. Now what will happen? Let us suppose in some time, let us suppose in time delta t, we have taken one cross section here. I named this cross section as x dash. If suppose through this cross section area in delta t time, we are having a flowing of charge is equal to delta q. So we say that delta t time charge flows is delta q. So in unit time, how much charge will flow as delta q by delta t, and this much is called as, this much charge is flowing in unit time, and we call it as current, and we call it as average current, because we are considering a interval of time delta t and we have equated to 1. Then we will say that average current is defined as total amount of charge flowing through a cross section area in given time interval. This is called as average current. Okay. This is time interval. It may be from 2 seconds to 3 seconds, 2 seconds to 4 seconds. It can be like that. Okay. Now, if suppose through this conductor only, earlier we are considering interval of time. Let us consider now charge is flowing through this cross section area, and suppose we are interested in finding how much charge will flow in 2th second. I say not 2th. Let us take 3rd second. That means 3 seconds to 4 seconds. 3rd second. If we want to find time at any one instant of time, not in an interval, but at an instant of time. Let us suppose t is equal to 2 second, or 3rd second, or 4th second, not 4 second. T is equal to 4, not 4 second, because it means 0 to 4. But we are telling 4th second. That means at an instant. To find this type of current, what we do? We take like this. We say I is equal to, instantaneous can be write as I, small I or capital I, is equal to, we write like this. We take limit, mathematics of use of limit, delta t tending to 0. If we make this delta 2 very small, that means it will become how much? We are putting this delta t very small. It will become very small. Let us say dt. In this small interval of time, we will get small time, and we call it as dq. So our instantaneous current is equal to, I is equal to what? dq by dt. And similarly, from here we can write like this: dq is equal to IDT, and then we can integrate here and we can obtain charge also. This type of numerical comes in your exam. Any problem, then we will solve some numerical based on it. Okay. Any problem in this introduction part? Any problem? Average current, instantaneous current, any problem? Should I explain it once more? Any problem? Please interact. Let me see. Okay. Nice. Let us take one example. Let us take one example. If it is given that I is equal to, it is given that one equation is given, I is equal to 2t square plus 3, and is telling that at t is equal to 2 second, it is given q is equal to 2 coulomb charge is flowing, and then it is telling that find current I at 4 second. I at 4 second. We have to find I at 4 second and I at 4th second. Okay. We have to find I at 4 second and 4th second. How to proceed? Let us see. How we can proceed here. See what we can do. It is given that I is equal to 2t square plus 3. Now we know that this I is equal to dq by dt. So we can say that dq is equal to okay. Let us find like this also. I at 4 second and I at 4 second, and also and q at 4 second. How much charge is flowing? How much, like this? How much charge flowed in 0 to let's say 2 to 4 second? This question. Okay. Now let us see. It is telling we can write like this: dq is equal to 2t square plus 3 into dt. Now let us integrate here and integrate here. We have to find charge from 2 to 4 second. We will put here time limit 2 to 4 second. And for charge, we have to find at 2 second how much charge is flowing. At 2 second, 2 coulomb. So we write 2 here, and upper limit we are not knowing. We can write here q. Okay. After integrating this, what we will get? We will get q minus 2 is equal to, integrate here, you will get 2 t3 by 3. You know integration. I am using this, plus 3t integration 2 to 4. You know integration. Any problem integration here? You know this formula. X and dx is equal to x n plus 1 by n plus 1. I am using this formula here. Any problem? Comfortable in integration now? What we can write? Q is equal to, send this to that side. We will write 2 plus. Now here we can write like this: 2 by 3 into 4 cube minus 2 cube plus 3 into 4 minus 2. What we will get? We will get 2 plus 2 by 3. Here 4 square 64. 64 minus 8. That means I think it will be 56 plus 4 minus 2, 6. You can add like this. It will be 2 plus, it is 112 by 3 plus 6. So we will get here q is equal to how much? There I think some point will come. 8 plus 3 by, I think some value will come, and you will get your answer. Itna coulomb. Any problem in solving this type of question? Any problem? You can see this type of question usually comes in your exam. Any problem? Okay, good. I think you know that. Very good. Okay. And similarly, you can find the current also. You can find the current also here using this formula. You know, since current is given, what is current is given, equation of current is given, I is equal to, you can see here, equation of current is given as I is equal to 2t square plus 3. So here we can see that if we will put I is equal to 4, we will put at in this here, it for t is equal to 4 second, we will put 4 here. What we will get? 2 into 4 cos square plus 3. This will be the answer, current at 4 second. Now to find current at 4th second, what we will do? We will find I4 minus I3. This will be the current at 4th second. Any problem here? Any problem in question? This question, any problem? Comfortable? Comfortable with the question? Any problem? Shall we move further? Any problem, or I shall repeat? Please respond. Okay. Solve this type of question. This type of question usually comes in exam. Now let us see Ohm's law. You can write here Ohm's law. Ohm's law. Do you know Ohm's law? V is equal to IR. V is equal to IR, and we can write like this. Also write like this. R is equal to rho L by A. And you know this rho. What is this rho? This rho is, what is this rho? This is resistivity of material. Okay, now resistivity of material. Now let us see one thing. Now let us see. If suppose in a conductor, if you are having one conductor, what happens? We will see all those terms. Now let us see. If suppose there is one conductor, at room temperature it is kept like this, what will happen? Room temperature, due to some thermal energy, how much thermal energy is equal to 3/2 kT. What will happen? A charged particle will do motion like this, zigzag motion like this, and it will return to a same place where it has started the motion. So at thermal equilibrium, I of current, total current, is equal to 0. Okay. So to move this, what we have to do? We have to apply some potential. So we will apply some potential here, V here, and suppose 0 here. Then potential difference will be V minus 0 is equal to V. When this V is increased, then what happened? Current is increased. So we say V is directly proportional to I. And when we remove this, a constant appears here, and the constant is called as resistance. Okay. We will see how much factor weight, how depends upon all those things. We will see it further. Now let us move further then. Okay. And you can see from here, R is rho L by A. L will increase, R will increase. If area increases, area is increased, R will decrease. Okay. These are the factors upon which our resistance depends. Okay. Now let us see current density. Next term. We know, suppose through a cross-section area, when we have taken one cross-section area like this, it is having area A, cross-section area. We define current density I is equal to current J is equal to what? How we define? We define J is equal to current flowing through this cross-section area by the area of cross-section. This is called as current density. So from here we can write like this. I is equal to, in vector form, it is in vector form, we can write like this. Current is equal to J is vector dot A. you remember this also in vector form. Or we can write like this, integration of j into d. We can use like this also. Weight is needed. Okay, any problem to anyone? Okay, now anyone any problem? You can discuss with me. Okay, now let us move further. You know how you know one more thing. You know one more thing. Yes. Let us see. Let us see. What it is telling that? It is telling that you can see. Yes. We know that V is equal to, we also know V is equal to how much? We know V is equal to E into L. V is equal to E into L. We know from electrostatics, V is equal to dV is equal to E dot dr. So V is equal to E into L. Now this is also equal to, from Ohm's law, I into R. R means rho L by A. That means we can say like this, L cancel from both sides. So we can write like this, and you can say what happens. I is equal to I by A into sigma and to rho. And we know I by A is J. So we can write like this. J is equal to E by rho. Rho is resistivity. Opposite of resistivity is conductivity. So we write J is equal to sigma E, like this. You should remember, this is very important formula. Okay, and this is conductive. What is sigma? Sigma area of material. Okay, and we say sigma is equal to Ne, and you should remember this. Okay, I'm not getting into the derivation part. You should remember this. What? Sigma is equal to Ne square tau by m. Now let us see how, on which conductivity depends. Conductivity n is number of free number of free charge particles per unit volume. This is n is charge of electron, m is mass of electron. Okay, mass of electron, and tau is equal to how much? It is average time. It is average time between two successive collision. I tell you all this. Don't worry. Collision. All it is called as relaxation time. Relaxation time. Now I tell you. Explain it once more. Let me see. Is there okay? No page. No worry. I tell you once more here. You see. You see. Why? What I did? Actually, what happened? What happened? If a charged particle was moving from here, it got collided with here. After that, it moves here, again collision, moves here, again collision, and so on. Collision goes on. Okay. Now, between this collision and this collision, let us say 1 and 2. Between this collision, how much time is spent? The average of this, all two successive collision, average of all those time is called as tau. Okay, this is tau. Okay, and we also know if there is electric field present. You know one more thing. If a charge is there and electric field is there, and we know A is equal to how much? Force. What is force? Force is charge to electric field by mass. And we get this formula, and from this I have defined sigma is equal to this, sigma this, you can see here. Okay, what is n? I have said here. What is tau? I have said here. M is mass of electron, and so on. Any problem here? Any problem? Now, let us move further. Now, let us move further. Let us move further. Let us move further now. Now, what I have tell you till now, it is also very, very important. You should remember. Okay. Now, what I told you. Suppose a charged particle started moving here. Okay. If we have applied some electric field, drift velocity is average velocity of electron attained in presence of electric field. In the presence of electric field, how much average velocity is attained? That average velocity is called as drift velocity. Suppose charge is moving here, collision occurs, it moves there, collision occurs, moves there, collision occurs, and so on. Okay, and finally it has started from here and finally it goes there. Then this is called as drift velocity in this direction. But why it happened? It happened due to presence of electric field. But if electric field is not present, then what will happen? This will ended here at the initial point only. But due to presence of electric field, it stops. It goes to a final point, which is some about drifted from initial point. So we said the velocity in this direction as drift velocity. Okay, and we know for an electron, we know acceleration is equal to E by m, and we know velocity. To find velocity, what we do? U plus at. Put the value of E and we get Vd is equal to, one more thing we know, how we define, we get Vd is equal to one formula, minus E by m into tau. This is the formula we get after the derivation. You should remember this. Okay, you should remember this. Okay, what is this? It is just acceleration, and you know V is equal to, and we know V is equal to U plus at. If suppose U is 0, we write V is equal to U at. What is A? E by m. And what is time? Average time? Tau. That only we have written here. You can see. Okay, I am not going to the derivation in depth. Only short derivation to remember this formula. Okay. Okay now. Any problem? Okay. Now let me define one more term, that is mobility. Mobility means mu. Mobility is defined as ratio of drift velocity and electric field. Magnitude of this. Okay, what we say? We say mu is this, and from here we can write like this: Vd is equal to mu into E. Okay, so, and we know mu is equal to also like this Vd. Vd is formula is this. You can see here formula of Vd is minus E, and we have taken mod. So only positive sign, E by m into tau by E. E get cancelled. What we get mobility? Mobility is equal to E by m into tau. You should remember this. Only just remember it by concept. No, you have to mug it up. Just you have to remember it conceptually. From here, what we can say? We can say that mobility is directly proportional to relaxation time and inversely proportional to the mass, or we can say as dimension of conductor. Okay, we will see it in a question also. Okay, any problem? These all are the basic part of current, and I know these are not so interesting part, so I am completing it initially. After this, when we will study circuit part, it will be very much interesting. These are not so interesting part that I know. Any problem to anyone? Till here, any problem? Okay. Now let's move further. Let us see. Now let us see some question. Okay. Let us see some question. Okay. Now let us see some question. I tell you one more thing. One more thing. Let us see. You know, drift velocity is very less. Very less. If drift velocity is very less, then how it is possible that usually asked how it is possible that we switch on a bulb and the lights get on. Usually this question is asked in your exam. How it is happening? Can you think how it is happening? Can you think how it is happening? Okay, it happens because as soon as we switch on, okay, what happens? Electron starts flowing in a conductor at each instant. At here electron at this instant, at this point, at this point, at this point, and if suppose bulb is here, so at this point also electron starts moving. And as soon as the electron flows in the bulb to nearest point, the bulb glows. It's never waste. It never wait for this electron to come here. The nearby electron, as it flows through the bulb, it glows. Okay, that's why when we switch on, as soon as that bulb glows. Okay, this question usually comes here in your exam. They ask this question. Now let us define something more. Okay, so first of all, you know, resistivity R is equal to, okay, let me take one question is usually asked in exam. Suppose I am having one wire like this. I'm having one wire like this. I'm having one wire like this. And as soon as I switch on here, the bulb glows. Then it is asked that as soon as I switch on, why bulb glows? What happens that as soon as I switch on, electrons flow at each instant. Electron flows at each instant, and the nearby electron, as it reaches the bulb glows. It never waits for this electron to reach at this side. As soon as the nearby electron flows through the bulb, it glows. So that's why what happens, as soon as you switch on, bulb glows, because the nearby electron, as it flows through the wire to the bulb, it glows. It never waits for this electron to reach here. Okay, that's why. Okay, now let us see this concept. What is resistivity? Now when we will see here. Okay, let us see. Okay, now let us see what is that. We know R is equal to rho L by A. Similarly, R resistance, rho is resistivity. We can say like this: resistance, how resistance is directly proportional to temperature. Similarly, resistivity is also proportional to temperature. And we say that resistivity, how is vary? It varies like this. At temperature T, resistivity is defined as rho naught 1 plus alpha T minus, we say if we are saying at T2 and T1, then it is T2 minus T1 like this. This is the formula of resistivity. Okay. And similarly, we can say R2 minus R1 into 1 plus alpha T2 minus T1. Okay. This is the formula of resistance. Okay. Now, we know resistivity and resistance formula, they are depending upon temperature. Okay, derivation not required. First important thing we can conclude from here, alpha is equal to temperature coefficient. Temperature coefficient. First important point for metals, for metal or conductor, for any metal or conductor, we have alpha is positive, positive temperature coefficient, and for semiconductor, alpha is negative. We say it like this. What positive means, when we plot alpha versus time graph, or we say like this, resistance, resistivity versus time graph for conductor, what happens, it increases with temperature. Temperature increases, resistivity increases. But for semiconductor, what happens, as we increase the temperature, resistivity decreases. Okay, so for semiconductor we have negative alpha, and for metals we have positive. This question I asked in your exam, so you have to remember. Okay, got it? Or any problem from here? Any problem? Got it now? Please respond. Got it? Okay, let's move further and see this example. It is telling a platinum wire resistance thermometer at melting ice. That means it is having resistance at 0 Kelvin, okay, 0 degree centigrade, and this is at boiling water. That means resistance at 100 degree centigrade, and this is at a hot bath. Not knowing the temperature, let it be RT. And there is one formula of temperature of platinum, that is RT minus R naught by R boiling minus R naught into 100 degree centigrade. Okay, use this formula and you will get the answer. Okay, this will be your answer. Okay, you will get what is RT given. You can see it is 5.2 hot bath. R naught at 0 degree centigrade, what is 5. You can see at 100 how much, 5.5, and R naught it is 5. Put all these values, you will get your answer. Okay, this is a special type of platinum wire thermometer. I just took this this question to show you that this is the formula. Okay, you should remember this formula for a platinum wire resistant thermometer. Okay, you can put these values and get the answer. Okay, now let's see some more examples. One question. If suppose it is given that alpha is equal to 0.00125 per degree centigrade, like this, and it is also telling that at 300 degree centigrade R is equal to 1 ohm, okay, and at then we have to find at what temperature R is equal to 2 ohm. You have to find temperature. I give you 10-second, 15-second time. You try this question. It is simply based upon this question. RT is equal to R is equal to RT is equal to R naught 1 plus alpha T. Based on this, you have to use this formula. Just use the concept and solve the question. I give you 10-second, 15-second time. You solve this question. Solve this question. Any answer you got, then please tell me. Any answer? Any answer? Please call me. Please answer me. Any answer? Okay. Let's see what will be the answer. How we can solve it. Let us see. What will be the answer? Let us see. It is given alpha is this, T given. Now we know that R at T temperature is equal to R naught 1 plus alpha T. Now, for 1 ohm, R naught into 1 plus alpha T is 300. Put it here. Okay. Second case, if R is equal to 2, then R naught 1 plus alpha. We have to find this T. Okay. Take ratio of both of this. Alpha is also given. You can find the value of T. This much recently get answer. You can do it. Yes or no? Or should I solve it? Please tell you can do it, or I should solve it. Solve, sir. Okay. 2 is equal to, if I take the ratio, what will happen? R naught 1 plus alpha. Value of alpha will be 10.00125 into 300. Okay. By R naught into 1 plus alpha T. Alpha is only R naught cancel. We can cross 1 plus alpha T is equal to here 1 plus alpha into 300. What we can do? We can write like this: alpha into 300 minus alpha into T. You can add 1 is equal to alpha, value of alpha. Alpha value is 0.00125 into 300 minus T. From here, you can solve. You can put here in the denominator of the LHS, and from here you can solve the value of, find the value of T. Can you do it? Can you do it? This value, solve this value. Yes, you should solve. Put these values in the denominator and then find the value of T. Okay. Let us see. We are having some good question, set of questions. Let us solve this. First question. I give you 15-second time to solve this question. Solve it. Get the answer we have discussed today. Any answer? Any answer? Okay, let me check it. Let me check. What it is telling? It is telling that Q is equal to this much at T is equal to current. We know, okay. Current I is equal to 4T plus 5. Okay. I think 13 is correct. Good. Second question, try this. Take 10-second time and try this. Try this also. 10-second time and try this. 10-second time, take and try this. Take 10-second time and try this. Any problem? Any answer? Any answer? Any answer? Any answer? Let us see. Okay. Simple question, rho L by A, I think you must have done here. Earlier also, R is equal to, if length is doubled, 2L, area of cross section is 2L, rho by an area of cross section is half. That means A by 2. It means 4 into rho L by A. That means we can say that R dash is equal to 4 times initial resistance. Okay, got it? Got it now? Got it now? Please tell. Okay. Now let's go to next question. Try this. Try this question. Try this question. All of you try this question. Try this question. Take 10-second time. Try this. Any answer? Any answer? Okay. D. Let me see what can be the answer. J and E are current density. Okay. You know one thing. J is equal to one formula is there, sigma E. You know, direction of current density and direction of electric field is always same. You should remember this. Direction of E and J is same. And we know if direction is same, then J dot E is equal to what? J E cos 0. So it will be positive now. How it can be negative? How it can be negative? Always you see here, J and E are in same direction. If they are in same direction, they will have angle of 0 degree. So it will be what? Positive. How you can say negative? Confusion? Confusion, you can ask. Any confusion? Confusion, confused? See. Okay. Let us see. This question. Try this question. Take your time. Try this question. Try this question. I think this is a simple question. Simple question. All things are given. VD is equal to J by NE formula. J means I by A and E. I given, you can see here. Area of cross section given, you can see here. N given, you can see here. And electronic charge, you know. You can put all these things, you will get the okay, you can get the answer by putting all these values. Okay. Okay, now you can get the answer. Okay. Yes, you can solve it. Now see this question. How to solve this? Try this question. I give you 10-second time, 15-second time. Try this. Take your time. Try this question. Try this question. Answer A, option A. Okay, let me check it. V1 and V2 are the drift speed here and here, and it's telling like this. Okay, let me see. We know drift speed is equal to Vd is equal to I by A into N into E. So here we can see Vd is variable and A is variable. How we know? Vd is inversely proportional to area. Where area is more, Vd will be more, Vd will be less. So we will say V2 will be less than V1. So let me check this only. Okay, good. Now solve this question. I think this will be last question. I think I don't remember, but solve this question. I give you time. I give you some time. Solve this question. Solve this question. Solve this question. I give you some time. Solve this question. Solve this, solve this, solve this. You can see, first of all, area is given, I is given, okay, and we have to find drift velocity. We know Vd is equal to I by A into N into E. That means I given, area given, E we know, only we have to find the number of free electrons per unit volume. So for n, what we can do? Okay, it is given 108 is the atomic weight, and also its atomic number. Okay, atomic number 108, and also given, it is given that length is 1 meter. From here, density given. You can see density given. We know density is equal to mass by volume. So mass is equal to, we can say, given mass is equal to how much? Mass is equal to density into volume. Density is 10.5 into 10 to the power 3. This is for density into what is volume? 1 meter length. Okay. You can see this is for how much volume? For 1 meter cube. You can write like this: 1 meter cube. For 1 meter cube, this much density. So mass will be this much. Okay. Now we can write number of moles. Number of moles. Okay. Let me see. Okay. Let me check. Number of moles is equal to given mass. You can calculate from here and divide it by number of moles, that is 108. After solving it, multiply it with Avogadro number, you will get number of atoms. Okay. When you will multiply this, okay, suppose you get y and multiply this y by Avogadro number, you will get number of atoms. Okay. In the number of atoms, we know one silver metal gives one electron. So this much silver atom will give this much of electron. Okay. We will get n from there. Okay. You put here n, e, I, n, you will get the value of Vd. Okay. And after solving this, you will get the answer. Okay. I am not giving the answer. That's why I can't give you the answer. You solve it. This is the process. You should solve it. Okay. Okay. Any problem, or I should solve it? Any confusion, or I should solve it? Please tell. Okay. I think we are going to end our session today only, because I also have some work, and also yes. So if you have any doubt, you can ask, or we will meet in our next class, I think on Monday, and we will and believe me, from Monday we will be learning very interesting part of current, all circuit part, all resistance part, circuit part, EMF, like that, and it will be very much important, very much interesting. Full numericals which we have studied in capacitor, that type of numerical. Today's class was some boring, that I know, because it was theoretical part. That's why I taught it today only. And I also tried my best to cut all the irrelevant points. So I have taught you up to the point which I asked in your NEET exam. Okay. If you have any problem in today's lecture, you can ask. Any problem in today's lecture? Let me check. Okay, good. If you have no doubt, then let me end the session today. We will have our next class on our next lecture. You can get a schedule also. So good night. Take care. Keep your study going on.